Number 23, two spheres with radii of r are in contact with each other and attract each other with a force F if the radii of both of the spheres are cut to half, while the density remains the same. What's the new gravitational force? The new gravitational force would be F prime. So let's set up a relationship between the original force and F prime. So the original force F is going to be equal to big G times the first mass, which is rho 4/3 pi r cubed, times the second mass, rho 4/3 pi r cubed, and all of that over r plus r quantity squared. And in the second situation, F prime, it's going to be equal to G times rho 4/3 pi. And for the first mass, we have to cut its radius in half. And the same thing with the second mass. And that's all going to be over one half r plus 1/2 r quantity squared. So when we set up this relationship, we can actually divide one by the other. So by dividing one by the other, this g that's in the numerator will stay in the numerator, naturally. This one will be in the denominator because multiplication is the inverse of division. So this g would cancel out with this g. Rho 4/3 pi. Same thing here, same thing here. So what are we left with here? So for the original force, we're left with r cubed times r cubed all over 1r plus 1r is 2r quantity squared, which would be 4r squared. Let's simplify this. No, let's keep it like that. In the denominator, we have 1/2 cubed is 1/8 times r cubed times 1/8 times r cubed. 1/2 plus 1/2 is 1, and r, so 1/2 r plus 1/2 r is 1r. 1r squared is just r squared. Simplifying this further, we can say r to the third times r to the third is r to the sixth over 4r squared. And 1/8 times 1/8 is 1/64 times r to the sixth all over r squared. All right, so we can say r to the sixth over 4r squared times the inverse of this, which would be r squared over 1/64r to the sixth. This 64 we can flip and put in the numerator. So let's see if we could do that. And put this 64 up here. The r to the sixth would cancel. The r squareds would cancel. So we're 64 over 4, which is 16 over 1, which is f to f prime. We can do a little cross multiplication here, and we're going to get force equals 16 times f prime, but in terms of force, f prime would equal force divided by 16, and D would be our answer.